Hello everyone, hope you all are doing good and welcome back to another video. In this video, I'm going to show you how to do haplotype analysis and how to construct LD blocks, how to visualize linkage disequilibrium blocks, that's LD blocks. And usually this haplotype analysis and LD blocks are done after GWAS to see is any haplotype has an association with any trait value. Whether there is a superior haplotypes or inferior haplotypes, you want to see the allelic combinations, the combination of the different genetic variants has any association with the trait value. So, so in this video, I'm going to show how to do haplotype analysis and LD block visualization through a software called Haploview. So Haploview is an open accessible software and it's open access is can used by anyone. And this is the paper where they published about the Haploview software, published in 2005 in Bioinformatics Journal. And if you want to know more about this Haploview software and the principles and all those stuffs, algorithms, you can refer to this publication. So next, so what is LD blocks? So before going to the deep into haplotypes and all those stuffs, I just want to mention a brief about LD blocks. So linkage disequilibrium blocks. The linkage disequilibrium is the non-random association of alleles at a different loci. It's a chunk of DNA or a chunk of segment of chromosome. The segment of chromosome is a very apparent word. Is a very big stuff. So you can just take a segment of DNA which is in LD blocks, which is in LD to each other, and they are inherited most oftenly together. So that's called an LD block. So suppose you can see in this markers are in LD block, one LD block, because they are associated with each other and they tend to inherit together most oftenly. And how different haplotype from LD blocks. So haplotypes are there inside LD blocks. These are a specific group of genetic variants or alleles on a single chromosome that are inherited together from one parent. So LD blocks is a chunk of DNA, a piece of DNA which is going to inherit it together. But haplotypes, the genetic variant, the SNPs in that, for example, there is a SNPs here, A, T, T. So whenever there is a SNP A, there is a T, T here. See, whenever there is a SNP A, there is a T, T here. And whenever there is a SNP G here, there is always A, A. So they have some non-random association. So A has an association with SNP T, another SNP T. So G has an association with another SNP A and SNP A. So it's a specific combination of genetic variants or genetic SNPs, single nucleotide polymorphisms, which on the same chromosome, which are inheriting together. And these specific combination has some biological value with it right to do something with that. So these are an haplotype. So this is the paper about the Haploview. You can just have a look if you are interested and if you want to know further about the software. And for the Haploview software, we should aware that we should need a Java runtime environment. You need to download Java runtime environment. That's also easily downloadable from Google and easily available. You can just type Java runtime environment and you can download from the internet. And after downloading Java runtime environment, you can download the Haploview software. You just need to type Haploview software. You will get it the software link and just download it and open it. So the background should be Java runtime environment. So there are two input files we need to provide for Haploview. There's a one file called fed file. Sorry. There's a one file called fed file. There's another file called info file. In the fed file, you give most of the snips, and you need to add some prefixes like 0010. And here the genotypes you need to number as a individual one, individual two, or you can number as G1, G2, G3, G5 till how many numbers you have. And this should be constant. This one should be constant for all the rows. This column the zero column here, 0, 0, 1, 0. This should be constant. And this, the genotype numbers, genotype 1, genotype 2, genotype 3, you need to number as a G1, G2, G3, G4. And this is all the allele data. So here, the info file, which has the marker name, support whatever marker name you have, the position of the marker. So you need to have a two file. It's all in the TXT format, text format. One is PDF file. Oh, sorry, Fed file. Sorry, one is Fed file and one is info file. And so after this, so what you want to do? So I will just show how to make Fed file and info file first. So just going from here. So I have, see here I want to do have a wheat genotypic data. So I want to perform the haplotype analysis or LD analysis for the 5B chromosomes. So these are the genotypic. This is actually I took it in the HapMap genotypic file format. So the column should be the SNP, the markers, the marker SNPs. This is 5B6417147 is a marker, and this is the allele for each the genotype. This is the genotypic column, and the columns heads are like the marker names. So I have several hundreds of the markers on 5B chromosome of the wheat, and you need to do this individually on each chromosome, separately on 5B chromosome, separately on 5A chromosome, separately on 5D chromosome, separately on 1A chromosome. So you need to do specific to each chromosome. So I'm doing specifically for showing as an example. I just took 5B as an example, and so this is my data arrangement where this is the genotypes, and this is the allele of each genotype on each specific marker. This is allele G, A, G, G, G. Like this, I have a 1,273 genotypes, till 1,273 genotypes, and I have the markers. So now I need to prepare this as a Fed file and info file. So initially, what I told to make an info file, we just need to take the marker position. This is the marker name and marker position. So this is the marker names and marker positions. Just go to another sheet, paste it in paste as a transpose them. So this is all markers name in order. So delete it. So we need a marker position. The position is next to these numbers next to the chromosome. 6417147 is the position. So paste it here. Just a shortcut. Go to your data. Extra column. Fix with. Just we need to separate this chromosome name with the positions. So these positions got separated and just delete it. So this is our info file. The info file is ready. This is the marker name and the position of the marker. Just save it as a txt format. Save as Haploview, and just save as an info file, and in the txt format, text.ms data format. Just save it. Okay, only this. The pop-up window showed you need it's just going to save the opened sheet, not all the sheets. So this we need to convert into Fed file. So I forgot to tell you in the Fed file, so each marker should be repeated twice. So suppose 5B6417147 having one column, it should be repeated again next to each other. So 5B6417147 1 year and 1 year. This all should also be repeated. So like that, all the markers data should be repeated twice. So how to do this? So we can do this in the R program. So I just saved this file in Excel. Show you. So I saved this next file. Just let's go to R program and let's set the working directory first. So set working directory. set working directory, Haploview, go like this. Yeah. So this all done, and then import the data set from Excel, browse. So this is the data set, open. Just it's a big file, so it's taking time. So just rename this as a SNP and everything same, all characters, import. And you can also see sometimes I can just show there is some zeros in the genotypic data. See here, there's a zero here. So this means, so there's a zero here. There's a zero here. So any allele other than A, T, G, C should be replaced with zero. Suppose sometimes there will be some confusion between A or T or G or C, so they will give some new alphabetic alphabets like N, R, Y, Q, M. So all these alleles need to be replaced with zero. Zero is missing data. The name of the meaning of zero is missing data. All should need to be replaced with zero. You can do it manually by Control F and Control Replace. And have been already replaced all this missing data with zero, and only ATGC alleles are there. So after this, download. So the first column is a the genotypic column. So it's just going to remove the first column. Suppose this is the genotypic column, and whatever the remaining this SNPs, the remaining SNPs here, it need to be repeated twice. So this should be repeated twice next to each other. This should come next to this only. This should come next to here. So next to one another. So this code I'm going to paste it in the comment box or wherever I could able to paste it, so that you can able to get access into this code. Then just download this is the code for repeating each genotype column twice. So suddenly the columns become 17088 double. So you can see 5B64171147 repeated twice. GG A GG GG. This is repeated twice. A. And I'm going to bind um, the, the the genotypic names and the repeated SNP data together is a C bind, and just going to save the SNP data into fed.csv, something like that. So save it. So I open it. So there's a fed file here, the saved file. So here, so if you go into the presentation, so see this is the format. There should be number one on first column, and this is genotypic numbers, and there should be 0010 all over the data set. So just go here, open this fed file. You need to delete this, delete it, insert columns, 6 columns, 3, 4, 5, 6. The first column should be 1, 1. Just grab it to land. And the second column should be genotypic number. Just we need to give G1, G2, something like that. So G1 to G1273. You can go till the end. And this should be 0, 0, 1, 0. This is constant. I don't know why we need to put this thing. That's how the software asks us to do that. And drag it again. drag it till the end. So again 0010. So our fed file is ready. So we need to so each, so you should also remove this one. You should remove this one. So what we can do is copy from here to here. We need to remove this marker names. So just delete it. Oh, it's too much. Too many markers. Just copy this somewhere here. Now the file. Initially delete this first. Delete it and copy this again. Yeah, so it's all done. There's two more. That's it. Till here. The first column should be 111 and the second column should be the genotype number. The third is a 0, fourth is 0 and 10 till the end of the data. So this is our fed file. So save this as, so this each snip is repeated twice. See, so save this as fed file in txt format. Fed the txt formats, that's in the txt mstr format. So it's saved. Okay, so our two files are ready now. One is info file and one fed file. So I already downloaded the Haploview. So I'm going to open the Haploview software. So there is the Haploview. The Haploview software is open. So the data file should be fed file. So I'm going to open the browse, the fed file here. Person technology start first up. Haploview, the data file. This is fed file. Open it. And the locus information file should be info file. This is the info file. Open it. Just press it OK. This is remaining constant. If you want, if you know more things about these things, you can alternate. You can just play over that. But I don't know much thing on this, so I'm going to keep this as a constant. Press OK. Uh, Showing an error. Maybe we messed up somewhere in the info file. Oh yeah. So info file should be. It should not have any. It should not have any column names. It has a column names, so that's why it's giving an error. So just paste it here, paste it again. So just a minute. Remove this info file. So it has rs here. This is the problem. So copy this. Info file. Why? Oh, info file. I think I did some mistake. I did save the fed file in the info file. So just a minute. So we need to make info file fast because it's all now the data is replicated. So yeah, we'll just make it info file. So I need to get this file again somewhere, the original stuff. So I'll just take those file again as for the analysis 5B files. Yeah, from here, just take this and put it in Haploview. Yeah. So this adds the single uh, the marker position. So this is the info file. Just copy it here and go here, paste it here, transpose, paste the special transpose, and you need to delete this. And I'm making info file again, so paste it here. Data text to columns, fixed with finish. So delete this. This is our info file. So copy this everything and make another info file. Paste it here and delete this info file. It's not required. This info file. This is the marker name and the marker position. Save as Haploview info file in the txt format, text format. Okay. So now our info file is ready. So this is the marker name and the marker position, and our fat file is also ready. So go here and just remove it, go to Haploview again, download, import the fed file, that's the data file, Haploview, fed file, and info file here, press OK. So it's got, you got everything, it's correct. And here go and press select all. So this thing I just leave it as it is. I don't want to change anything. If you want to change, you can change. And I'll just go and press select all, and then you'll go for haplotypes. Press haplotypes here. Just take some time. So you will see the haplotypes here. So there are some LD blocks here. If you want to see the LD plot, see it, you can see the LD plot here. So there's a LD plot. There's a 5B11477524, and these 5 SNPs are forming an LD block. There's a block, and another block here. There's a big LD block here. These are all red triangles, inverted triangles or LD blocks. And if you want to check this in the haplotype format, so this is in the haplotype format. So the LD blocks is in the haplotype format. And if you want to interested in an LD block, just go for snipping tool and snip this and save it as a file you need. Or if you want to export anything like that, like a picture from one snip to another snip, there is also a option here, export current tab to PNB, and you can also go for export options. There's a PNG, and you can choose the markers, whichever the markers, the 5B11606146 the 5B-1, you can choose and you can press OK, and it will save. You can save wherever it's possible. So this is how you make the haplotype analysis and haplotype. This is how you get to know what are the haplotypes. So 5B114725 so if you go here, so it has block 1. This is block 1. This is block 1. So block 1 is a CTGCC, CCCAG, TCGAG. So this is one haplotype. This is another haplotype. So this is haplotype 1, haplotype 2, haplotype 3, haplotype 4. This is haplotype 1, haplotype 2, haplotype 3. So each blocks has different haplotypes. So this haplotype might be superior, this haplotype might be inferior. The genotypes which is having this haplotype might be showing more yield. The genotypes which is having this haplotype showing less yields, you need to find out. So based on the LD blocks and the haplotypes, you need to make an association with the biological value. That's the Fright value. So which haplotype, which combinations of an allele is giving superior yield? Which combination of allele is giving inferior yield? So this is how the haplotype analysis is done. and I'm going to paste all the codes in the comment box or in the wherever it's possible. And yeah, if you have any doubts, just type it in the comment box. I'm going to reply whenever I get a time. And let me know if I need to make any other further video on this, or if you want more an extra video on this, I can also make it. Just comment on the comment box. And oh yeah, hope you enjoyed the video. Yeah, thank you very much, and all the best. See you in the next video.